Hello, welcome to Time classes. Today's class we are going to discuss the second exercise of basic concepts of chemistry. Here we will solve the problems based on chemical equations. Okay, so let's start. Look at the first question. What is the first question? First question is the molecular mass of Na2CO3 is. So already you know how to calculate the molecular mass. I think your last class also I have discussed that you have to have your notebook and pen ready with you. So start working on it. So how will you calculate the molecular mass? Previous exercise also you have worked on it. So here the formula is Na2CO3. So you need to know the gram atomic mass. Here we will not say gram atomic mass because it is given molecular mass. So let us say atomic mass. So I will first write the atomic mass of the constituent elements. From there you will calculate the molecular mass. Suppose the atomic mass of sodium is 23, right? Carbon is 12. Oxygen is 16. Now you have to work on it and calculate the molecular mass of sodium carbonate, that is Na2CO3. Let's proceed. I hope you are ready. Okay, so what we will do first, we will look at the formula. Formula is Na2CO3. So 2 sodium atoms are there. So let us write 2 into 23. Since 2 sodium atoms are there, plus 1 carbon atom is there, plus how many oxygen atoms are there? Good, 3, right? So 16 into 3. This 2 into 23 and 16 into 3, and then you have to calculate the sum. Fine? Okay. I hope you are done with the answer. So shall we look at the solution? Okay. So let's look at the solution. The solution is molecular mass of sodium carbonate is 106. Fine. Let us look at the next question. The next question is equivalent mass of calcium in calcium carbonate is. So for this, how do you calculate equivalent mass? Already you have studied in the basics. Again, we will discuss it in the class. Calcium in calcium carbonate. What is calcium carbonate? What type of substance it is? It is a salt. So how do we calculate the equivalent mass of a salt? Equivalent mass of the metal present in the salt, that I will discuss first. Then I will get into the problem. Fine. Suppose, okay, let us take the example as calcium carbonate since we have to work on it. Okay, so calcium carbonate. So what is the metal present in it? Calcium. We have to calculate its equivalent mass. For that, what we have to do? We have to take the atomic mass of calcium atom. So equivalent mass is equal to atomic mass divided by valency of the metal, atom present in the salt. Okay, so now work it out. Atomic mass of calcium, we must know about it by this time. You must have remembered also this. So this is 40. What is the valency of calcium atom? So many problems you have done based on that. So you must know about its valency. Not only that, you can derive it from the formula also. If you know the valency of carbonate radical, it is -2. Calcium, only one atom is there, so its valency must be +2, right? So divided by 2. So we are getting 20. So equivalent mass of calcium is 20. Understood? Okay. So with this we will move on to the next question. Equivalent mass of calcium is 20. I think you are done with this. Our next question is the atomic mass of hydrogen atom is. The atomic mass of hydrogen atom, here don't get confused. One thing I would like to tell you, atomic mass means the mass of the single atom, the relative atomic mass of the single atom. So for hydrogen it is 1. But if I ask you molecular mass of hydrogen, then what it will be? So then you have to consider the atomicity of hydrogen. So hydrogen gas is a diatomic gas. So in one molecule there are 2 atoms. So molecular mass is when we are talking about molecular mass, you have to write the formula of the molecule. So this is the symbol, this is the formula. So H2. So what will be its molecular mass? So 1 into 2 is equal to 2. Fine. And gram atomic mass 1 gram. Gram molecular mass 2 grams. Fine. Okay. So the atomic mass of hydrogen atom is 1. Okay. 1 AMU. Atomic mass unit. If we say atomic mass, molecular mass, then have to use the unit AMU or U. AMU is atomic mass unit and U is unified mass. But if I ask you gram atomic mass, gram molecular mass, then you have to use unit G. Fine? Okay. So let's look at the solution, then we will move on to the next question. So the atomic mass of hydrogen atom is 1 AMU. Fine, good. So we'll move on to the next question. The reaction between Fe2O3 and carbon produces. Okay, first what we will do, we will write the reaction. Okay. So Fe2O3 plus, what is the name of Fe2O3? I think everybody knows about it. It is ferric oxide. Here why ferric? Because the valency of iron is 3 here, plus 3. So it is reacting with carbon. So what will be the product form? See, carbon will act as a reducing agent here and Fe2O3 is the oxidizing agent. So Fe2O3 will release all its oxygen and it will give it to carbon. So what will happen? Iron oxide will be free from oxygen and it will be reduced to iron, whereas coke or carbon will be oxidized to carbon monoxide. Okay. So let's see the solution and then move on to the next question. Are you done? Yes. Okay. So iron and carbon monoxide. Fine. Okay. We'll move on to the next question. An unbalanced chemical equation is called. It is a very simple one. You must know about it. What is that called? Before balancing, the chemical equation is called skeletal equation. Okay. After balancing, it is called balanced equation. So it is skeletal equation. Let us see the answer. An unbalanced chemical equation is called skeletal equation. Fine. Now let's move on to the next question. Next question is the difference between the molecular mass of the oxides of iron is. Okay. So here we have to work out. First we have to see what are the different oxides of iron. Different oxides of iron are FeO and Fe2O3. Right. Now you have to calculate the molecular mass of both of these and then you have to find out the difference. So molecular mass of FeO, how will you do it? FeO, in atomic mass of Fe is 56 and oxygen is 16. So what is the answer? 72, right? Now Fe2O3. You do it. I'm waiting for you. Okay. Now you know the atomic mass of iron and oxygen both. So how will you do it? Iron atomic mass 56, you have to multiply it by 2 plus oxygen is 16. Since 3 oxygen atoms are there, you have to multiply it by 3. So 112 plus 48 is equal to how much? 160. So what you have to do? 160 minus 72. Fine. Let's look at the solution. So solution is molecular mass of FeO is 72. Molecular mass of Fe2O3 is 160. The required difference is 88. So choice is 3. Okay. Fine. So let's move on to the next question. The gas produced on heating calcium carbonate is. Fine. So which gas can be produced when we heat calcium carbonate? Not only calcium carbonate, the carbonate salts. In the previous exercise also we have discussed about it. Calcium carbonate, it has a carbonate radical. Since it has a carbonate radical, so on strong heating it gives calcium oxide plus carbon dioxide. All the carbonate, most of the, or we should not say all, most of the carbonate salts, they produce carbon dioxide on heating. There are few exceptions. In that, two common examples I'm giving. One is, note it down, Na2CO3, another one is K2CO3. There are some more examples, but these two are, you are familiar with these two salts, so I'm mentioning these two, Na2CO3 and K2CO3. Further, when you will learn periodic table in 10th class, then you will learn a better knowledge about it, and you will see that what are the some more salts, because you will be then familiar with many more elements. Okay, so as of now, sodium carbonate and potassium carbonate, since you are familiar to these salts, so they on heating do not release any carbon dioxide gas. They are highly thermally stable. So most of the carbonate salts, when you are heating, they release carbon dioxide gas. Fine. Okay, so we'll move on to the next question. So answer is carbon dioxide, choice is 2. Let's see the next question. The gram molecular mass of oxygen. What is the gram molecular mass of oxygen? Options are also there. Now, what is the formula of oxygen? Just in the first question I discussed, I think you have remembered that. Gram molecular mass and gram atomic mass difference. When you are using a symbol, a single atom of oxygen, then this mass of this oxygen atom in grams, we say gram atomic mass. Okay, and when we have to calculate gram molecular mass, we have to write O2, the formula of oxygen. So O2 is the gram molecular mass, and this is gram, and when we are writing O, then it is gram atomic mass. So what will be the gram molecular mass? For that we need to know gram atomic mass. Gram atomic mass, GAM of oxygen, is equal to 16 grams. Let me erase this. So it is not 16 AMU. If it is only one atom, then it is 16 AMU. Otherwise, it is 16 grams, because we are saying gram atomic mass, so it is 16 grams. Now molecular mass, gram molecular mass for O2 is equal to 16 into 2 grams. I think you are ready with your answer. So answer is 32 grams, choice is 2. Let's see the choice. Choice is 32. So we will move on to the next question. Next question is equivalent mass of zinc. So again we are handling with equivalent mass. Already I said equivalent mass of a metal, how to calculate the atomic mass of the metal divided by its valency. Now valency. If a metal like iron, it has a variable valency. It can have +2 and +3 valency. So again equivalent mass for iron, let us take example as iron. We take ferrous oxide and ferric oxide. And in these cases, if I ask you that what is the equivalent mass of iron, then for FeO, there you have to consider the valency as 2. For Fe2O3, the iron is exhibiting +3 valency, so there the valency has to be considered 3. But equivalent mass of zinc, it is very clear, zinc doesn't have any variable valency, its valency is 2. So how do you calculate equivalent mass of zinc? Equivalent mass is equal to atomic mass divided by valency. Okay, so you know about it. So atomic mass of zinc is 65.3 divided by valency is 2. So you calculate and you will get the answer. Let's see the options first. 32.5, 65.3, 16.32, 21.7. So I think you are ready with your answer. It is choice 1, right? Okay, so 32.6. Now we will move on to the next question. Next question is, in a balanced equation, what are same? So let's see the options. The number of molecules of reactants and products are same. The number of atoms of each constituent element of reactants and products are same. The valencies of the constituent ions of reactants and products are same. All the above. So now let's discuss. Okay. The number of molecules of reactants and products. Let us take an example. Already we have taken it. let us take Fe2O3, what we have already worked out, Fe plus CO. Now what we will do, first we will balance the equation. So already it was balanced and you are ready with this, fine, okay. Now the number of molecules of reactants and products are the same, look at. So left hand side there is 1 molecule of ferric oxide and 3 molecules of carbon, right? In the right, so total how many molecules are there? 1 plus 3, that means 4. And right hand side 2 Fe, 2 iron, molecule also you can say, or atom also you can say for iron, because it's a monoatomic molecule, means in one molecule there are only one atom, there is only one atom. Now carbon monoxide, there are 3 molecules of carbon monoxide, so total is 2 plus 3. Are they same? No. So first option is obviously not correct. The number of atoms of each constituent element, according to the law of conservation of mass, the total mass of the reactant has to be equal to the total mass of the product. So we definitely have to add up, like that is the reason we are balancing the chemical equation, so that the number of atoms of each constituent element becomes same in the right hand side and the left hand side, that is in the product and in the reactant. Then only this will follow law of conservation of mass, fine, okay. So you know about it very well. So the number of atoms of each constituent element of reactants and products must be same in the balanced chemical equation. That is the reason we are balancing the equation, fine. The valencies of the constituent ions of reactants and products, are they same? So let us see. Here you can see iron, it has plus 3 valency, but here it didn't form any compound, so we consider its valency is 0 here. It is not combined, it is not in combined state, right? So the valency is changing. Similarly, you look at carbon, here the valency is 0 because it is not in a combined state, but here you see it is plus 3. It is plus 2. Oxygen valency, carbon monoxide, oxygen valency is minus 2, so carbon is plus 2. Understood? So here you can see that the reactant and product, the valency of the carbon is changing. So it is not mandatory that balanced equation, the valency must be same. In certain equation you may find it same, that equation is not considered oxidation reduction reaction. If the reaction is an oxidation reduction reaction, there must be a change in the valency. Okay, so now even in an oxidation reduction reaction, there could be some elements which valency does not change. So we see in this case we will work out for oxygen. You see Fe2O3. What is the valency of oxygen here? Let me change the color. So it is minus 2, right? 3 oxygen atoms are there. So minus 2 into 3, total charge contributed by oxygen is minus 6. Iron is plus 3, 2 iron atoms are there. So it is plus 3 into 2 is plus 6 and minus 6. So compound as a whole is neutral. Okay. So here oxygen valency, what we are working out? We are looking at the valency of oxygen in Fe2O3, that is minus 2. Now let us look at the valency of oxygen in carbon monoxide. So let us change the color of the ink so that we can understand it properly. So oxygen, it is here minus 2 and carbon here it is plus 2. See, look at in the reactant Fe2O3, in that oxygen is there whose valency is minus 2. In the product carbon monoxide is there, in that oxygen whose valency is minus 2. So valency of some of the elements have changed. We have seen iron and carbon, their valencies have changed, but in case of oxygen there is no change in the valency, although it is an oxidation reduction reaction. If it is not an oxidation reduction reaction, then there will be no change in the valency of any of the elements, right? Okay, I feel you could understand, fine. Okay, now we will look at the other options. Valencies of the constituent ions of the reactants and products in a balanced chemical equation. So this may change or may not change, or may be same or may not be same. So we cannot say are the same. So that is wrong. So we will consider it as wrong options because it is not written as may change or may not, it is written are the same. So it is not always the same. So it is wrong option. So all the above is not possible. So the second option is the correct option. Fine. So let's move on to the next question. You understood the problem? Okay. So solution is the number of atoms of each constituent element is the same. So choice 2. So let us move on to the next question. So now we will study about some knowledge based questions. These are subjective questions but simple questions. Okay, let us start. Identify the diatomic molecules from the following. Let us see. Hydrogen, sulfur, phosphorus, chlorine, ozone and iodine. Let us work out. So what you have to do? We have to identify the diatomic molecules. Can you tell me what do you mean by diatomic molecules? Diatomic molecules means the one molecule of that element contains two atoms, two constituent atoms. If a molecule of an element is constituted of two atoms, that molecule is called diatomic molecule. Now let us see. Hydrogen, H2, diatomic molecule. Sulfur is an octatomic molecule, S8. Phosphorus is a tetraatomic molecule, P4. Chlorine is diatomic. Ozone is triatomic. Again, iodine is diatomic. So what are the diatomic molecules? Hydrogen, then chlorine, then iodine. Clear? Okay, very simple question. We'll see the solution. Solution is hydrogen, chlorine and iodine are diatomic molecules. Let us move on to the next question. Let us look at the next question. Identify the polyatomic molecules from the following. Okay. Now let's work out. Ozone. Ozone is O3. Phosphorus, P4. Sulfur, S8. Carbon, only C, monoatomic. Zinc, it is a metal. All metals are monoatomic. Zinc. Hydrogen, H2. All noble gases are monoatomic. So neon is a noble gas. Helium, neon, argon, krypton, xenon, radon. Radon is a radioactive element. So these are the noble gases. All the noble gases are monoatomic. Fine. Okay. Now you see polyatomic. What do you mean by polyatomic? Monoatomic, diatomic, polyatomic. If it is more than 2, then we consider polyatomic. Phosphorus is polyatomic. Sulfur is polyatomic. Let's check the solution and then we'll move on to the next question. So ozone, phosphorus and sulfur are polyatomic molecules. Let's look at the next question. Next question is state the law of conservation of mass. See, law of conservation of mass in general, we present it in this way, that the mass of a substance can neither be created nor be destroyed. So mass, we cannot destroy it or we cannot create it. Only we can convert it from one form to the another through a chemical reaction. So in terms of a chemical reaction, if we state law of conservation of mass, then we should say that the total mass of the reactants must always be equal to the total mass of the products. That's the reason we are balancing chemical equation also. Okay, so let's see that. Let's see the answer and we will highlight the key points also. Fine. So the law of conservation of mass states that the total mass of the reactants taking part in a chemical reaction is equal to the total mass of the products. Okay. So what we will do, we will highlight. Fine. Okay, let me take a different color so that you don't get confused. Okay. So what are the important aspects? The total mass of the reactants. So don't forget to write that total mass of the reactants in a taking part in a chemical reaction is equal to the total mass of the products. Remember that reactants, products and mass, their mass must be equal. That's the reason we are saying that this law is law of conservation of mass. So these highlighted parts are the key points of your definition and always remember to write this. Fine? Okay, we'll move on to the next question. Next question is, what is the relation between equivalent mass and atomic mass of an element? So equivalent mass of an element is atomic mass divided by its valency, right? So let's check the solution. Solution is equivalent mass of an element is equal to atomic mass of the element divided by valency. Fine? Okay. We'll move on to the next question. So next question is, what does the symbols, you can see the double-headed arrow and a triangle sign, indicate in a balanced chemical equation? The double-headed arrow, you know, that is a reversible reaction. Fine. So, and the triangle sign shows that it is heating. When we are heating an equation, when we are heating a reactant, then we have to symbolize it as delta. Let me show it. Suppose a reaction, let us take an example. Single example, I will show you the both. Calcium carbonate. I will write double-headed arrow. Why I am writing, I will tell you. Calcium oxide plus carbon dioxide. These reactions will not take place unless we are strongly heating it. So here we write the delta symbol. This triangular symbol is called delta, capital delta, and it indicates heating. Okay. And why did I use a double-headed arrow? Because the reaction is reversible reaction. Means the reactant will first start decompose and then again it will move on to the opposite direction. That means at the beginning calcium carbonate will decompose to form calcium oxide and carbon dioxide. After some time calcium oxide and carbon dioxide will combine to form calcium carbonate. Then the reaction will be stagnant, means it will not move neither in the forward direction nor in the backward direction. The rate at which calcium carbonate decomposes, the same rate calcium oxide and carbon dioxide will combine to form calcium carbonate again. This kind of reaction is called reversible reaction. Followed? Understood? Okay, let's check the solution and then we will move on to the next question. The solution is, the symbol double-headed arrow indicates the reaction is reversible and symbol delta represents heating. Fine? Okay. Now we'll move on to the next question. Define the following. Relative atomic mass. Relative atomic mass, relative word means it is a comparison. So let's see the definition, then I will highlight the keywords in it. The definition is, the mass of the atom of an element is calculated with respect to the number of times the atom of the element is heavier than 1/12th part of carbon 12 isotope. Okay, first let me explain it. When we are saying something relative, relative means what? Always a comparison. What we are doing? We are comparing. That means we are like the mass of an oxygen atom, we are comparing how many times it is heavier than 1/12th of carbon 12 isotope. That's why it is relative atomic mass. Now 1/12th of carbon, the mass of 1/12th of a carbon 12 isotope is equal to 1 AMU, 1 atomic mass or unified mass. Okay, so in this way if we calculate, then we will find the relative atomic mass of oxygen is 16 AMU or 16 unified mass U. That means one atom of oxygen is 16 times heavier than 1/12th of carbon 12 isotope. The 16 times heavier than the mass of 1/12th of carbon 12 isotope. Fine? I hope you could understand that. Let's see in other definitions. Equivalent mass. Already you have studied about equivalent mass. Okay. So let us see first the definition. The equivalent mass of an element is defined as the number of the parts by mass of that element which can displace or combine with 1.008 parts by mass of hydrogen or 8 parts by mass of oxygen or 35.5 parts by mass of chlorine. Okay, I will explain you this. Fine? Okay. Now let's understand the definition of equivalent mass clearly. Okay, so let me discuss about it. So what is given? The equivalent mass of an element is defined as the number of parts by mass of that element which can displace or combine with 1.00 parts by mass of hydrogen. Okay, first let's start with this 1.008 parts by mass. Now, why it is considered 1.008 parts by mass? Since the gram atomic mass of hydrogen is 1.008 gram, or the mass of a hydrogen atom is 1.008 AMU. Okay, this 1.008, this fractional value is because of the existence of three different isotopes of hydrogen in the atmosphere. They are protium, deuterium and tritium. Protium has one proton and no neutron, so its atomic mass, its mass number and atomic number both are 1 and 1. For deuterium, atomic number is 1 but mass number is 2 because of the presence of one neutron and one proton. For tritium, atomic number is 1 whereas the mass number is 3 because of the presence of one proton and two neutrons. The average atomic mass from the natural sample of hydrogen, if we calculate, then we get 1.008 AMU or U unified mass. If it is gram atomic mass, then we write 1.008 grams. Okay. So the equivalent mass of an element is defined as the number of parts by mass of that element which can displace or combine. Let us understand these 2 points now. So I'll explain you with the help of a reaction. Suppose if you take hydrogen and oxygen combine to form water. Fine. In this case, you can see that 2 molecules of hydrogen combines with one molecule of oxygen to form 2 molecules of water. Fine. So 2 molecules of hydrogen means what is its mass? 1 molecule of hydrogen, its mass is 1 molecule of hydrogen, its mass is 2 AMU. Right. So 2 molecules of hydrogen, its mass will be 2 into 2, so 4 AMU. So what I can conclude from the reactions by seeing the reaction, and before that we have to know that what is the molecular mass of oxygen also. The molecular mass of oxygen, atomic mass of oxygen is 16 AMU. So in one molecule there are 2 atoms, it is a diatomic molecule, so its molecular mass is 16 into 2, that is 32 AMU. Fine. Now, if you are discussing the definition of equivalent mass, then look at the definition. The equivalent mass of an element is defined as the number of parts by mass of that element which can displace or combine with 1.008 parts by mass. For the time being, we will consider 1.008 as 1 because 1.008 will make your calculation very difficult. So let us consider it is approximately equal to 1. So let us consider 1. Okay. So 1 AMU of hydrogen, we have to see with that how many AMU of oxygen is combining, right? Because here hydrogen is combining with oxygen to form water. Okay. So we can see that 4 AMU of hydrogen is combined with 32 AMU of oxygen. So 4 AMU of hydrogen combining with 32 AMU of oxygen. Clear? So 1 AMU, because it is combined with 1.008 parts, means we are considering it as 1 part. So 1 AMU of hydrogen will combine with 32 by 4, that is 8 AMU of oxygen. That means equivalent mass of oxygen is 8. Clear? So 8 AMU of oxygen combines with 1 AMU of hydrogen. So equivalent mass of oxygen is 8. Fine? Or 8 AMU. Okay. So that is the part combined. Now displace. I will give you another example so that you can understand that displace. So for this we will take a reaction for zinc with sulfuric acid. Okay. So you know already hydrogen preparation in the lower classes. I think you have studied about hydrogen preparation. So what is the reaction when zinc reacts with dilute H2SO4? So write down the reactions on your book. On your notebook you write the reactions, then I will start discussing. Okay. So zinc plus H2SO4, dilute H2SO4 gives rise to zinc sulfate plus hydrogen. Now coming down to the equivalent mass definition, combine already we have seen. So what is the significance of displace? There we will see. So you can see that one molecule of zinc, which is a monoatomic molecule. So for zinc, for any metal, atom and molecule is the same because it is monoatomic in nature. So one molecule of zinc displaces one molecule of hydrogen. So what is the molecular mass of hydrogen? Already we have seen it is 2 AMU. That means 2 AMU of hydrogen is displaced by one molecular mass of zinc. That is nothing but 65.3 AMU. Okay. So what is the definition? Says that displace by one parts by mass of hydrogen. That means it is 2 AMU, you have to consider for 1 AMU. So 1 AMU of hydrogen is displaced by 65.3 divided by 2 AMU of zinc. Right. So 65.3 divided by 2, that is 32.6 approximately AMU. So what is the equivalent mass of zinc then? 32 by 6. Why? Because it is displacing this 32.6 AMU of zinc is displacing 1 AMU of hydrogen from its compound. Clear? Okay. So this is equivalent mass with respect to hydrogen. Now if you look at the definition, hydrogen, after that 8 parts by mass and 35.5 parts by mass of chlorine. Now what is the significance of giving oxygen and chlorine also, and how it is 8 and why it is 35.5 in case of chlorine? Let's see that. So for that we have already seen that equivalent mass of oxygen. What is the equivalent mass of oxygen? Just now we have calculated based on the combination with hydrogen. We have seen that 8 AMU is the equivalent mass of oxygen. So all the elements may not combine with, they do not combine with hydrogen. But most of the elements they combine with oxygen or chlorine. That is why always if you take only hydrogen, one part of hydrogen by mass, then we cannot calculate the equivalent mass of many elements. So that's why for our convenience of calculation, so that we can get a combined substance, we can see that this much of oxygen is combining with other element, this much of chlorine is combining with other element, then only it will be easy for us to calculate the equivalent mass. So that's the reason we consider oxygen or chlorine. Now already you have seen that 8 AMU is the equivalent mass of, is equal to the equivalent mass of what? Equivalent mass of oxygen. Fine. Oxygen. So now in the similar way how I have explained for hydrogen, the similar way it is for oxygen. So we have to see that other element which is reacting with 8 AMU of oxygen, the mass of the element which reacts with 8 AMU of oxygen, that is the equivalent mass of that particular element. Similarly, suppose hydrogen and chlorine, hydrochloric acid or hydrogen chloride gas. So here you can see that one atom of hydrogen is combined with here capital C, okay, and small l. So one atom of hydrogen is combining with one atom of chlorine, okay. So one part of hydrogen, its atomic mass is for hydrogen atomic mass is 1. And its equivalent mass is also 1 because the valency of hydrogen is 1. So equivalent mass is equal to atomic mass by valency. So since the atomic mass of hydrogen is 1, equivalent mass is also 1. So one molecule one atom of hydrogen, that is 1 AMU of hydrogen, combines with one atom of chlorine. What is the atomic mass of chlorine? 35.5, isn't it? That's the reason we can say that 35.5 AMU of chlorine combines with 1 AMU of hydrogen. So what is the equivalent mass of chlorine then? Chlorine equivalent mass is 35.5 AMU or unified mass. Okay, this is equivalent mass of chlorine. That's the reason it is in the equivalent mass definition, we are using 8 parts by mass of oxygen, because the equivalent mass of oxygen is 8, and 35.5 parts by mass of chlorine, because the equivalent mass of chlorine is 35.5. Always remember that one equivalent mass of an element always combines with the one equivalent mass of the other element. So next question is again definition. Atomicity. Very simple definition. Let's see the definition. The number of atoms present in one molecule of an element is called atomicity. So let us, we have already discussed some examples. I am giving some more examples, like hydrogen, if you say it is atomicity is 2, ozone if you take its atomicity is 3, sulfur if you take its atomicity is 8, like this. Okay. So let's see the next definition. Next definition is atomic mass unit. Already we have discussed when we are discussing about the relative atomic mass of an element. So what we have seen at one atomic mass unit, what is this definition? The mass of 1/12th part of the carbon 12 isotope is called atomic mass unit. So the mass of 1/12th part of carbon 12 isotope. So remember that one more thing, that you can unit, you can write either atomic mass unit or you can write U means unified mass. Okay, fine. Now let's see the next definition. Gram atomic mass. So what is gram atomic mass? The atomic mass expressed in grams is called gram atomic mass. The relative atomic mass. So relative atomic mass or atomic mass, both are same. So the relative atomic mass of an element expressed in grams is called gram atomic mass. I hope it is clear to you. Fine. Next, we'll move on to the next question. Next question is, how do you indicate a gas in a balanced chemical equation? I hope you know, it's very simple, an upward arrow, or we write G in the bracket. Suppose I am showing you an example. Calcium carbonate on strong heating gives quick lime, which is a solid, and a gas carbon dioxide. So we write here the upward arrow, or we can write or these or G. Fine. Okay. So let's see the solution. So a gas is indicated by an upward arrow.